Good afternoon, ladies and gentlemen. I'd like to welcome all of you to the last presentation for Diverse Engineering on the School of Engineering. Today I'm going to present to you the final design review for our product, and we are very excited to show you some of the stuff we have today. In the beginning, I'd like to go over my team. Myself, team manager, I'm doing project task documentation, critical design analyst. We have Cameron Buck, he's doing all design documents, budget, logistics stuff, public relations manager. We have Carmen Karanji, he's a functionality development and design constraint analyst. We have Anthony Atty, he's our main project designer and SolidWorks modeling. Also, we have our advisor, our great advisor, Dr. Briguier, and Dr. Cohen, he's department coordinator for us, mechanical engineering. So, in the beginning, I'd like to go over the product, a quick overview over the product. What we're making is a portable vehicle access system. It's a very simple device that helps older people, injured, disabled people get in and outside of cars. It's not just made for older people. It's made for you playing football, you get injured, you can't move your bag for a while, you can buy it, and you can use it again to get in and outside of cars. Also, it's entirely mechanical. This device does not have any batteries, any motors, no wires, does not need high maintenance, nothing. It's very simple to use. It is made for everyone above the age of probably 15, 16. They can very simply use it. And also, it's portable. You can just install it. It does not need any modifications to your car. You don't need to drill holes in the car. You don't need to attach any hooks. Nothing. It's very simple. You just put it in the seat, and it works. You get done with it, you take it off, put it on the trunk, and that's it. And you move on. It's very simple to use, really. So, also I'd like to go over some of the constraints we have. In the beginning, we had some geometrical constraints. That's when we had our quarter scale model to get over these geometric constraints, because the device cannot interfere with the vehicle design already. So we have the door does not open 90 degrees, so we had to overcome that. We had the roof of the car, you can't hit the roof, so you had special height for the device that you can't exceed. Also, some of the materials, we had to go through some iterations through the materials to get a light and durable material.
I'm so sorry.
Another thing is the seat navigation. It has to be very smooth in movement, so it doesn't get stuck when you're sitting on it. So it stays safe, it doesn't bump you over, it doesn't push you out of the car when you're not ready for it. It's very smooth to use. And the lateral strut support, the legs in the bottom, they just, when they are expanded, they support your weight, and you guys will get to see it in a second. You'll be very happy, but you'll see. So some of the iterations we went through was, first iteration, this was during Senior Design 1, was just a brainstorming quarter scale model. We actually got a quarter scale car, little kid's car, and we made a very small prototype, and it worked great. We had some sketches. This was just brainstorming and making some things to overcome the geometric constraints that we had. Second iteration we had was SolidWorks. So this is the phase when we started designing it in SolidWorks, drawing things, trying to visualize how this thing will work in real life, and trying to see how this thing will come from a computer program to a device that we can use right now. Also during this phase, we went outside and went to a couple vendors. We started looking for materials. We got some aluminum, which is durable, and it's very light to use, and it's a lot easier to manufacture than other materials. And we also got some steel bearings, some U-bars. Everything you see here, we got in this phase. Also, the third iteration, which is the final iteration we have, which this phase right here led us to this design right now. This is the one where we started fabricating all the materials we had, started welding and assembling everything. As you can see in the slide here, we have all the pictures. You can see this is the U-bars before they get cut. This is the swivel seat. This is the swivel flat bar that the seat swivels on. This is the thing when it's getting assembled. And now, this is after the seat is assembled on top of it. Here, this is fully expanded. And the final expanded version of the product when it's in use now. So right now I just like to invite my teammates, Cameron Butt and Carmen Karanji. They'll give you a quick demo, very quick demo of this, how this thing works. Please enjoy it.
All right, ladies and gentlemen, so it's a quick demo. Basically, Carmen here, what he's doing is he's expanding right now the device is installed within your car. So you gotta imagine with me for a minute, okay? He's expanding our legs and the rail system from the inside. He's installing push pins, which we've used temporarily for our prototype. And as the second leg comes out, we're preparing the device so that somebody can sit down on it and we can push them in. In a minute or so, Carmen is going to invite me on the scary task of actually sitting on it, and I cross my fingers and I hope it works. I'm just kidding, I know it works. So, the point of this is that it's quick, it's easy, and look, he's already done by
So
time.
that would be an automatic thing. This is just beta prototyping. So then this comes out on top of the rail, so and it's free to rotate. So now a
I'm just
car
going
will
to
face this
move this up a little bit so you can see me get on it.
Take a seat, buddy.
So,
Sits down just like it's a normal chair.
works,
Turn him around.
turn me
Send
around,
him in.
send me in, push those legs in. See, simple as that. I can put my coat on, my seatbelt on,
And then you shut the door.
shut the door,
You're
walk
done.
away, drive away.
That's all you have to
That's
do.
all you have
And
to
then
do.
you just do the reversal to bring him out.
That's it, right?
That's it. You drive your car, close your door, and drive away. That's it. You don't have to do anything else. One more thing I'd like to add. You saw all this work that he did in the beginning, expanding everything, putting the pins. That pins will be automatic. Like pins will be a push pin. It will be spring loaded. This is just a beta prototype. That's why all of you right now, you can see the seat. This plastic base right here, if you can see it, this sits on the seat. It should be contoured, but it's not for the purpose of demonstration here, because we can't have a contoured plastic base on the wood, on a flat wood. But when it's contoured in the seat, this thing will just sit on there, and once you pull them out, once you pull the legs out, you extend them, the lock pins will lock in place according to the dimensions, to the clearance between the floor and your car height. So that's how we know this works for every car height. So if you have a higher car, this will still work. If you have a lower car, you have a coupe, this thing will still work with it. That's everything you have to do. No more carrying your grandparent to the car, no more hustling inside, no more pushing someone inside and injuring your own back in the process and needing someone else to put you in. You don't need any of that anymore. That's it. So some of the testing we done in this product, this testing was done before we actually manufactured it. This was old SolidWorks. We did a lot of stress tests on it, and every component, at least for the legs right here, as you can see, it can hold up to 500 pounds. This device, we are making it for 400 to 450 pounds, 400 to 450 pounds person, which is pretty much, it will withstand your weight, that's for sure. And that's what the testing has told us already. For real life testing, we just saw this thing work in front of all of you. Okay. Alright. So during senior design, basically what we were trying to do from the beginning is visualize a whole concept from an idea to bringing something to paper and a computer model, and then bring this computer model to a real life device, and after that you test this device to make sure it's working. After we've done all that, I think we succeeded so far in doing that. We did all the testing we needed, and I think right now we can say we have designed practical and proof of concept device that you can manufacture, and we're planning on marketing this device. This device is not just going to be for a senior design project anymore. No, this device is going to be marketed. Which brings us to the next thing. Our team, we're competing in School of Business for the Be Your Own Boss Bowl competition. It's one of the most respected competitions all across the U.S. with more than 300 judges. And my teammate here is handing out flyers. Actually, I'd love to see all of you in the presentation. Final presentation and reception is next Thursday from 2 o'clock to 6. Please come support us. We'd like that. One more thing. Diverse engineering right now, as of now, it's not just a senior design team in the School of Engineering. Actually, we just filed for a charter. So now it's Diverse Engineering LLC. We're starting a little company of our own, and that's how we're planning moving forward. Another outstanding thing that's actually making me happy in person, we filed for a patent. So this device now, it's patented for, it's not yet patented, but it's pending patent for Diverse Engineering LLC, which brings us to some more future planning. This brings us to more options for different cars. What if you have a higher car, very high car, a Jeep, a 4x4, a truck? We can make this work with some hydraulic lifts, and of course with the proper machining and proper facilities, we can make this way lighter and smaller too. So it will be easier to use. Everything you see now, as easy as it is now, we're planning on making this easier. And some of our business plan includes by next year, this product will be in dealerships, it will be distributed by healthcare providers, and we're already in contact with all of them. Also, by the end of next year, or the beginning of 2015, PVAS, the Portable Vehicle Access System, will be in every car for the people who need it. This thing, you can buy it in Target, you can buy it in Costco, it will be everywhere. Okay? Any questions, concerns?
So I've seen something like this before and tried it myself. It wasn't sliding though. It was just rotating, which is the essential part, because you open the door, in most cases you can sit, right on the seat when you open the door. Then the problem with people who have, legs or arthritis and problems, then they cannot rotate, they cannot move inside. So the rotation is the key part. So that one is you can buy it, and it's thin, and it's nice. You just sit like it, and then you just lift a little bit your legs, and you can do it by yourself. You don't need anyone. But even if it is quite thin, it's a couple inches and it swings a little bit, it makes you high. On
Well,
the car seat. This thing is
Yeah,
massive.
this thing is high right now, I understand that, but again, this is only for a purpose of prototype demonstration. We could not get enough resources to make the seat smaller, that's why we ordered a pre-made seat already. This was ordered, this was just assembled on top of it. This seat has 3 inches cushion, which we don't really need if we made it on our own. Also, to answer the first part of your question, I can put something to swivel on top of a car. However, a lot of the disabled people and older people have problem raising their legs. So if this thing is higher, if it saves you 3 to 4 inches of raising your leg, then this saves you the effort of having someone bending down, trying to get your leg, one leg at a time inside a car, and then swivels you. And at the same time when you're swiveling, the other thing does not provide the motion that we provide inside, which makes it easier for you. You just sit on it. You don't need to do anything else. That's the best part about it.
Yeah, but you need someone to push you. I mean, if someone wants to drive the car, wants to be independent.
You want if it's someone to drive the car with it?
Now, if someone drives the car, is this for driver or for?
This is for a passenger right
for
now.
a passenger.
Yeah,
Okay,
one of
okay,
the
because
future
okay.
plans is making it for a driver, but that will require, if you cannot move your leg at all and you want to drive the car, that will require a motor in there that will push you in there by itself.
Okay.
So this is made for passenger cars so far.
The only works, of course.
Okay.
So, have you done a financial analysis?
Yeah, we did that for our business plan. Yeah, we're breaking even, actually the break-even point is in 11 months after we start the business, which is starting hopefully in like 2 months from now. We have a startup cost, everything. We're gonna be outsourcing the machining for the first 18 months, just to save money from buying $50,000 mill machine, something like that. We're gonna be outsourcing and subcontracting small parts and different vendors, and then the assembly we're gonna do on our own.
And the price point?
The price point, okay. This brings us to the price point and selling it.
You would.
First, huh?
Alright, go ahead.
Yeah. First thing, dealerships offer you $1,000 if you need a device for getting inside of cars if you are disabled or older, if you're buying a new car, of course. So they're offering up to $1,000, and we can prove that. So this device will be selling for $800 to $900. We're not sure what the exact price is yet, but we'll be selling from $800 to $900, which brings us up to like 65 to 70% profit margin.
That's coming from
Yeah, of course, which is covered by the automobile, so we're selling older people something, or disabled or injured people, something that you don't have to pay for. You'll get a check and you'll get a product. That's it. That's all you have to do. So I'm giving you something to help you get inside a car without paying for it, pretty much. And it's covered by most insurance, it will be covered by most insurance companies. We check the policies for them. It has every specific that they require, and for dealerships and the Government Disability Act.
So do they cover the purchase of something that helps you get in the car if you're a driver or if you're a passenger?
For the owner of the vehicle.
For the owner of the vehicle.
So for the driver,
No,
the
it's-
owner of the vehicle, okay.
Mhm.
If you have your own driver.
Any other questions? Yes.
So the final product will be portable, correct? They
Well,
can
this
move
is
the
portable. The
car.
only reason it's not portable now is
Right.
that it's in this desk. This is right now it's 40 pounds, and we're still cutting a lot more. The personnel safety it's defined by, I think, Department of Health, that an individual above 16 years old can carry up to 35 pounds in his own. So this is right now, it's 40 pounds. However, after we cut everything and after it's not a beta prototype, again, I'm stressing that this is a beta prototype. It's not the device we're selling. It will be under 35 pounds for sure. It will be between 28 to 32. We already have plans on starting that very soon to start everything. Yes?
Does this have to be secured to the?
Yeah, it has seat belts, which we cannot demonstrate right now because we don't have a back of a seat or we don't have a car seat.
Once you put it in the car, it actually.
Yeah, it said the contour
In
on
an
it
accident, it
sits.
can't fly off.
No way it will do that because
Because it doesn't depend.
no, the center of gravity for it,
It's a regular seat.
after analysis, the center of gravity for it will be sitting on top of the seat, so it can't flip over. It's just very simple center of gravity calculations. Also, it has a back seat belt that around the back of your seat, so it's very secure in place. And once you get in there, you just fasten your own seat belt, and now you're very safe twice with the back seat belt and the regular car seat belt. Anything else?
Well, this is really interesting, and everybody here is excited for you.
Thank you. Thank you.
But we have to move on.
Yeah, sure. Just one more thing, please. I'd like to just thank one person, really. If not for this one person, this product will not be here right now. It will not be accomplished. Very special thank you to Dr. Pradier.